Google Maps knows traffic before you reach the road. Ever wondered how? How does it magically say heavy traffic ahead, 12 minutes delay? Now is Google spying on us? Today I'll break down the real tech, AI and the algorithms behind Google Maps traffic predictions in the simplest way possible. Welcome back to Tech with Saara, where we decode tech, AI, and coding in the simplest way possible. If you're new here, hit subscribe and let's dive into the magic behind Google Maps. Now, where does Google get this traffic data from? Well, Google uses three major data sources to get all of this information regarding traffic. Well, the first one is real-time GPS data from phones. Millions of Android users send anonymous location and speech data. And if many phones slow down on the same road, it means there is a traffic jam that is present in that particular area. Now, since several Android users are sending all of these location and speed data information, if this particular process slows down on a particular road, a traffic jam is detected instantly there. Well, the second one is historic traffic data. Past months or years of traffic data, including weekdays, weekends, festivals, rush hours, all of this is accumulated. For example, Fridays at 6 p.m. This is generally slow in your city. That means over the past years or over the past months, Fridays 6 p.m. have seen heavy traffic. So all of these observations, all of these patterns are stored together and this forms historical traffic data which lets Google get all of the traffic data to reflect it back to you. And the third one is government and partner data. Road sensors, toll booths, public transport, data, accident reports, road construction alerts, all of these information, all of these alerts from official sources are reflected, and this is how Google gets the traffic data from these official sources, right from the toll booths, public transport data, or any kind of construction alerts that it receives. So Google Maps combines all of this into one large traffic pipeline, processing millions of data points every second to deliver accurate predictions. Now, since Google has to give accurate predictions, it will require proper and real-time data. And to get this real-time data, it takes all of this from real-time sources, namely real-time GPS data from phones, historic traffic data, to understand the patterns of what's been happening from the past few months or years, and government and official sites for the same. Talking about the core algorithms behind this traffic prediction. Well, maps use algorithms like Dijkstra's algorithm and A-star search to find optimal routes. And here the world is treated as a huge graph where every road is considered an edge, every junction is considered a node, and weight is equal to the travel time. Now we all have heard about this Dijkstra's or the shortest path algorithm. Here we have edge, node, and time, and the entire map or graph is treated or considered along with these edge nodes and time. Similarly, following the same thing, world is considered as a huge graph with several edges, nodes, and weight being the travel time here. Predicted traffic updates these weights in real time, allowing the algorithm to continuously recalculate the fastest route. Now you might see how Google constantly changes the fastest route and how all of this is calculated so instantly. Well, this is because Dijkstra's algorithm is in place there. Every road is considered an edge, every junction is considered a node, and weight is the travel time. Now, if the travel time increases, that leads to an increase in weight, and this would affect how the shortest path would be calculated, and thus recalculation would happen, and then Google would again give us the shortest path considering all of these changes in a very dynamic manner. Google follows the speed estimation model, where current speed is the real-time speed of vehicles on the road right now. Typical speed is the expected speed for that specific time and day, and then it calculates the traffic status such that if the current speed is much lower than the expected or the typical speed, well, there is heavy traffic. And if the current speed is much higher than the typical or the expected speed, well, there is low traffic. So Google calculates the difference between current and typical speeds to determine congestion levels and to provide accurate traffic warnings to users. Not only do these speed estimation models or the Dijkstra's or the shortest path algorithms play an important role, but machine learning models also play a very important role for traffic prediction. Now, as we all know, machine learning is very widely used for applications pertaining prediction. And that is why Google uses ML to predict traffic 15 to 60 minutes into the future. Not only real-time data insights or real-time traffic insights, but Google uses ML to predict traffic which is even ahead. And for this, we use LSTM networks, long short-term memory networks for time series speed prediction to analyze how traffic patterns evolve over time. And also graph neural networks. These are referred to as GNNs, and these models have interconnected roads, and this way they analyze how traffic in one road would affect the other road, because all of the roads overall are interconnected at the end. Deep learning regression is how models estimate delays by considering multiple factors simultaneously. So these models would consider the real-time speed, weather, road events, density patterns, historical trends, and special events nearby like concerts or matches. Since there are several factors taken into account, it would give a very accurate prediction at the end. Well, that is why Google would have to use ML algorithms to predict what would happen or how the traffic would look like in the near future. And to make this prediction, it would take into account the most important factors like real-time speed, weather, road events, density patterns, historic trends, and certain events, and then use the most popular ML prediction models like LSTM networks, graph neural networks, and deep learning regression to do the same. Understanding real-time incident detection and how Google actually is able to detect any anomaly. Well, Google's system constantly monitors for sudden changes and unusual patterns on the road. For example, if there is sudden drop in speed across multiple vehicles, if user reports accident, road closed, construction, or if there is sudden spike in congestion signals. With all of this, Google gets real-time incident detection data. Well, all of this depends upon detection speed, user feedback, and instant updates. And using all of this, Google is able to detect any anomaly and then is able to signal us with high traffic ahead. Well, now let us understand how Google calculates the estimated time of arrival or ETA. Well, this is done by a simple formula which is road length divided by predicted speed plus delay factors. Well, it all depends on all of these factors such as traffic signals, which are stop lights and intersection, congestion level, road conditions, how is the surface quality and type of the road, accidents, incidents, any kind of blockage, elevation, hills and terrain changes, turns and intersections, and then the weather such as rain, snow, and visibility, since they directly affect the traffic. And Google recalculates the estimated time of arrival every few seconds, ensuring you always have the most accurate arrival time based on the current conditions. Well, the estimated time of arrival is directly calculated by this formula that considers the road length and the predicted speed also taking into account the real-time delay factors, how signal, congestion level, elevation, and weather would affect the overall traffic. And this way, Google recalculates the ETA every second depending upon the real-time conditions, and this is how it is able to give us the most accurate prediction, the most accurate arrival time based on all of these conditions. Well, understanding why Google is so accurate is all because of the huge real time data it gets. Millions of data points are processed every second from global sources. And there are several advanced machine learning algorithms that improve it with every prediction. All of this depends upon several global sensors, worldwide network of sensors and data collection points. And we do have constant feedback from millions of users, which helps to refine these predictions. Now, because it learns 24 by 7, it continuously improves its accuracy, and this way, Google is really accurate when it comes to predicting the traffic or the expected time of arrival or the distance or time in that case. Thank you so much, everyone. If you liked this video, drop a like, hit the subscribe button, stay tuned for more.